My name is Yujin. I'm the host of the show. Today we're going to be talking with Chang from Lance. I guess you're treating Lance like the file format as a database. Do you see people having to update their database often?
Yeah, so the file format is the core of the database. It's not the whole, it's not the whole thing.
Right.
But yeah, people update that pretty often. So this is actually this is actually a great question because there's another limitation of Parquet. I think it's great that Parquet chose to make files immutable because uh, that's what the constraints are for object storage.
Right.
And so when people update that, it becomes very difficult to deal with that. So we've introduced a lightweight, we call it table format in Lance on top of the data format, so that when you insert rows and columns or just do updates, a new file is created, and we automatically version this data so that you always see the latest data, but then you can also go back and do time travel, roll back to a previously good state. This is really ideal, especially for AI, when you are doing lots of experimentation or like you're rolling stuff out into a production system, like for either training or search. And in previous jobs, like errors happen, right? Like as much as we think that we write code that's perfect, you know, it's or maybe like you guys do, and other people's code are buggy, right? And that's
Oh,
what
sure.
causes production problems. But when that happens, like in previous jobs, like rollbacks were always like a big deal. You had to like reload the database and then like switch it over and do like a bunch of that Indiana Jones switch out the golden head thing. Whereas with LanceDB, because the original data is still immutable, you can just say like, okay, now point to like latest version -2 or -3, or like point to the latest version as of yesterday, so that rollback process becomes essentially instantaneous. And so for you might not immediately need that when you're doing just like local experiments and just playing around with stuff.
Yeah.
But for people who are managing large scale data sets in production that are changing constantly, or if you're like running lots of experiments and you want to keep track of everything, in those two use cases, it's extremely useful to have that safety of like, just like I can roll back to a Git SHA for code, and I know exactly the code that's going to be running. I can also roll back to the version number, and I'll know exactly the data and the order of that data that I'm going to get at that version.
Oh, okay. So the way that you would update data in Lance is to version it. With some other vector databases, and I'm not really sure like how all the vector databases work, but with some of the other vector databases, and I know Lance isn't a vector database, but I'm just from this framework.
We're not just a vector database. We can definitely do vector database things.
Okay. Well, with some other databases, let's just go a little bit broader. What you would do to delete or upsert data is you would find an ID and then remove that like row, and then you would index the new data. And so in this case, instead of, let's say, like I don't know, in memory kind of like doing that, what you would essentially do is create a new version that you can access, and then you would always be accessing X version of the data, and that is how you would make sure that you have updated data in production.
Right. So LanceDB is not LanceDB is not designed to be a like LLTP transactional data store with strong consistency.
Okay.
And so it's essentially like updates. So deletions are soft deletes, right? So essentially you mark certain rows for deletion, and then the reader then does not return those rows, or does not consider those rows.
Yeah.
And updates are essentially a deletion followed by an addition.
Okay.
And then so then the updates and deletions are eventually consistent. Um, and and then like LanceDB has capabilities around, okay, after a certain amount of changes, then let's compact those, and we call them like materializing the data, which is actually deleting removing the deleted rows. And so compaction and cleanup also happens in the background. So
Okay.
that's sort of the trade-off. You're not like we're not OLTP store, so you don't have like live transactions with strong consistency, but you get the other benefits of like eventual consistency around like scale and searchability. So we're much more like large scale data management, like like feature kind of like feature store ish, and like vector database ish.
Oh, okay. Okay. Oh, interesting. So it's like kind of like an interesting mix between these two like things that have been around for a while, and it's like it's okay. That's cool. How do you handle like large scale writes?
Yeah, I mean, so it's sort of like Lance is a LanceDB mostly takes advantage of Lance format to handle large scale writes, and so you can have essentially concurrent writers that are writing Lance to Lance, and they'll be writing into different fragments, for example, and then we use optimistic concurrency. So one of the interesting things that like building around Lance format allows us to do is to make bulk data loading very, very easy, so that like if you have 100 million vectors or a billion vectors, you don't have to sit there and say like, HTTP API, here's one batch of 1,000. Okay, here's
Yeah.
another batch of 1,000, and you get to try to get to a billion. Instead, you can just have like you can spin up a Ray cluster or a Spark cluster, be like, okay, write this like all of the nodes, write your shard of the columnar format, and then once it's done, index it, and then like, okay, like LanceDB, like use this is your new table, and then it's much faster. So we're working on some actually large scale demos to illustrate that,
Oh,
and essentially, it's sort of like you should be able to ingest and index like the internet in you know like in the span of like minutes and not like hours or days.
wait,
And
what?
we should be able to do that like pretty cheaply.
That's a lot of data.
Yeah.
Okay.
So I mean, if you like, let's say like if you take modal for example, and you're
Okay.
running like if you're running your embeddings on like modal or in a GPU or a Ray or Spark cluster, it's pretty easy to get up to like you'd be able to embed 100,000 rows per second.
Yeah.
And so then then if that's typically the bottleneck, but then if you solve that, that's really fast, and you can certainly write to columnar formats really fast, and you can then have distributed indexing that's pretty fast, and that becomes like a solved problem.
Oh, that's okay. Oh, that's wild.